Hey guys, it's Mr. Regan. Today we're going to look at multistage probability. Multistage probability is like if I want to find the probability of more than one event. Now, where earlier in the year we found what's the probability of flipping heads on a coin. Now we want to find out what's the probability of flipping heads on a coin 3 times in a row. So now we're doing it more than one time, hence the multistage. Right, so that leads us to this problem. What is the probability of flipping heads 2 times in a row? Earlier in the year, if we were doing this problem, we probably would have gone ahead and drawn a tree diagram. We would have labeled first flip. We would have said you could flip a heads or you could flip a tails. We would have put the probability on the branches. Heads would have been 1/2, tails 1/2. Okay, we would have done our second flip because we said 2 times in a row. So we would have labeled second flip. We would have heads and tails again, heads and tails again. Still 1/2 for heads, 1/2 for tails, 1/2 for heads, 1/2 for tails. We would have then our outcomes column. And that would be all the things that could happen. I can just follow the branches. Heads, heads. So that's one outcome. I could have flipped heads both times. Heads, tails. Could have flipped heads first, then tails. Tails, heads, or tails, tails. And then our last column would have been our probability column. And the probability column would come from multiplying the probabilities on the branches. So for our heads, heads, we see that we have a 1/2 and a 1/2. So 1/2 times 1/2, 1/4. Heads, tails, 1/2 times 1/2, 1/4. Tails, heads, 1/2 times 1/2 is 1/4. And tails, tails, 1/2 times 1/2 is 1/4. So then that's where the probabilities would have come from. And then the question is, what is the probability of flipping heads 2 times in a row? Well, heads 2 times in a row is right there. We already have our probability right there. The answer is 1/4. Right, well, now we want to do a problem like this and get an answer to a multi-stage probability event, but without making a tree diagram and doing all that. So if you look closely, you realize that all we're doing is multiplying the probabilities on the branches. So if I were to now ask like the same similar question, what's the probability of getting tails first, then heads? Well, I would just say, well, tails is 1/2, heads is 1/2, multiply them together, and my answer would be 1/4, and I wouldn't have to go through all that. All right, let's look at another example. What is the probability of flipping heads? Now we're doing 3 times in a row. So I really don't want to draw a tree diagram because now it gets bigger and more confusing. So let me just go back to what I just did there. So I'm flipping 3 times in a row. So I'm going to draw 3 lines. Now this goes back to the counting principle idea when we were multiplying, how many of this and how many of that and how many of this. We made these little lines here. We put the numbers on them and we multiplied them. Well, this is the same idea, except for these are going to be fractions, so multiplying like that. So what is the probability of flipping heads 3 times in a row? All right, well, flipping heads is 1/2 for the first time. Flipping heads is 1/2 for the second time. Flipping heads 1/2 for the third time. Multiply those. 1 times 1 times 1 is 1. 2 times 2 times 2 is 8. And 1/8 is our answer. And we're going to keep all our answers as fractions. So that was real quick, real easy, without having to make that big tree diagram. All right, what is the probability of rolling a 4 on a number cube 3 times in a row? All right, so I'm going to do that 3 times in a row. All right, so 3 fraction bars. I'm multiplying. All right, probability of rolling a 4 on a number cube. There's 6 numbers on a number cube, so there's 6 possible things I could roll. And rolling a 4, well, that's one of those 6. So 1 out of 6. 1 out of 6 for the second roll. 1 out of 6 for the third roll. Multiply across. 1 times 1 times 1 is 1. 6 times 6 times 6 is 216. 1/216. Okay, very little chance. What is the probability of rolling a number greater than 4 on a number cube 3 times in a row? All right, this problem's a little different. So I'm rolling 3 times in a row. So here come my 3 fraction bars. Now, there's 6 numbers on a number cube, so there's 6 things that could happen. We're looking for greater than 4. So how many numbers on a number cube are greater than 4? Well, we have a 1, 2, 3, 4, 5, 6. There's 6 numbers on a number cube, and these are the only ones that are greater than 4, 5, and 6. So that's 2 out of the 6 numbers. So 2 out of the 6 for the first roll, 2 out of 6 for the second roll, 2 out of 6 for the third roll. And you might notice those fractions could have been simplified. I could have made them 1/3 times 1/3 times 1/3. Either way, when you multiply across and then simplify, you're going to get 1/27. Alright? Alright, if the probability it will snow is 3/7, what is the probability it will snow 2 days in a row? Alright, so we're looking at 2 days in a row here. 2 fraction bars. Multiply in between. Alright, so I want to know what the probability will be it snows 2 days in a row. Well, the probability it snows is 3/7 for the first day, 3/7 for the second day. So the probability it's going to snow, 3 times 3 is 9, 7 times 7 is 49. Alright, now let's look at another problem here. What is the probability it will snow the first day and not snow the second day? So we're saying snow the first day, but not snow the second day. Alright, so we're still looking at 2 days. So let me make my 2 fraction bars, multiply in between. So snow the first day. Well, we know that it's going to snow 3 out of 7 times. So if it's going to snow 3 out of 7 times, it's going to not snow the rest 4 out of 7 times. It either snows or it doesn't snow. Well, just because the fractions are different, no big deal. Multiply. 3 times 4 is 12. 7 times 7 is 49. Now I get 12 out of 49. Alright, if we are given a 4-digit numerical password, what is the probability that all 4 numbers are even? Oh, interesting. Alright, so we have 4 digits. So let's do our 4 lines. We're multiplying in between. Alright, so when we're talking about each individual digit, we're talking about those numbers 0 to 9. And we all know that there's 10 numbers from 0 to 9. So let's put a 10 there. So out of those 10 numbers, how many of them are even? Alright, well, we know that 2, 4, 6, and 8 are even. We're also going to consider 0 as even. Okay, so 5 numbers out of 10. So for all 4 of them, 5 out of 10, 5 out of 10, 5 out of 10. Now you might notice that you could have simplified them, and it could have been 1/2 times 1/2 times 1/2. Either way, when I multiply across and then simplify in the end, I'm going to get 1/16. And that's the probability that I'm going to get all 4 numbers that are even. Alright, if we are given a 4-digit numerical password, what is the probability that all 4 numbers are less than 4? Oh. Okay, so we're talking about 4 numbers again, so let's get our 4 fraction bars. All 4 numbers are less than 4. So we know that this can be out of 10, because each digit has 10 numbers it could be. Less than 4. Let's think here. 0, 1, 2, 3, 4, 5, 6, 7, 8, 9. They're all the digits from 0 to 9. So less than 4 would be these guys right here. Remember, you don't include 4. So it looks like there's 4 numbers that are less than 4. So 4 out of 10, 4 out of 10, 4 out of 10, and 4 out of 10. Could have simplified, and it could have been 2/5 times 2/5 times 2/5 times 2/5. Either way, once I multiply it, I simplify, I'm going to get 16 over 625. Alright, our next one. What's the probability that I choose a vowel out of the first letter and a vowel out of the second? Or the vowel out of the first word, bat, and a vowel out of the first word, really. Alright, so I look. In bat, there's one vowel, A, and really, I have 2 vowels. We're not going to count Y in this example as a vowel. So, just like the problem before, I have 2 words, so I'm going to have 2 fraction bars. I'm going to multiply. The first word, probability of me getting a vowel is 1 out of 3. The second word, the probability of me getting a vowel is 2, and there's 6 letters altogether, 2 out of 6. Multiply those together and simplify, and I get 1/9 is my answer. All right, that's probability with multi-stage events. Good luck with that, guys.